afternoon, everybody. My name is Andy Katz. As Colin said, I'm a product manager at AWS. I'm based up in Vancouver, so a little bit north of here. Today I'm going to talk to you about media processing workflows using a service I take care of called AWS Step Functions and machine learning services that are available today on AWS. Now, quick question. I know today is ImageCon, and we're talking about images, but I'm curious, how many folks in the room are also starting to do things with video? Okay, maybe a bit more than half. So we're going to talk about both today. And we're going to talk in the context of media and entertainment. So what do we mean by that? So AWS has a whole family of media and entertainment solutions, and they take a variety of forms. So they can be native solutions, which are run on AWS behind an API that you can use as a fully integrated solution. We'll talk about what some of those look like. You can build things through partners. We have a huge partner network, and you can work with those partners who have domain-specific expertise to help you get up and running quickly. Or we have a complete set of core services that you can use to build your own custom solution from the ground up. So what do they look like? This is the stack for AWS Media Workflows. It includes things for ingestion of content, storage of content, processing of that content, and delivery of the content. And today I'm going to only talk about a couple of things. Whoops. These. So we're going to talk about Amazon Rekognition, an ML service for video and image analysis. We'll also talk a little bit about comprehend, translate, and transcribe for handling text-to-speech and speech-to-text. And AWS Step Functions, which is a workflow orchestration service that helps stitch all these things together into end-to-end workflows very easily. So we'll start by talking about the Amazon machine learning stack. We have 3 layers in the stack. At the top are application services with things like Rekognition, which you've probably heard of, but also some new services like Transcribe and Translate, transcription of audio to text, and translation of that text into other languages, as well as Poly for text back to speech, Comprehend for natural language processing, so getting sentiment analysis of a block of text, and Lex for building automated chatbots. Next layer in the stack are platform services, so if any of these API-driven services don't meet your needs, you need a different kind of machine learning model, you can build your own. And Amazon SageMaker is a platform for doing that. Similarly, for machine learning on video recognition, AWS Deep Lens is a toolkit for learning how to do machine learning models with video. And if you're a data scientist and you want to get really deep down in the weeds, we also have frameworks and interfaces at the ground up. So things like MXNet and TensorFlow and Gluon are useful on EC2 instances with GPU processors on the side for doing very, very deep learning neural nets. Today we'll talk about Rekognition, and then a little bit later on, some workflows with Transcribe and Comprehend in the mix. So start with Amazon Rekognition. Rekognition is really deep learning-based image and video analysis. You can do things like in an image, look at object, scene, and activity recognition. It can pull out faces. In those faces, it can extract things like, are they smiling or frowning? Are they have a beard? Are they wearing glasses? They can track people moving through a video. They can look for unsafe content. So if you're worried about something that is forbidden, like presence of alcohol in a scene. Celebrity recognition, it can identify celebrities from a database, and if it's a celebrity that you think is important that it doesn't recognize, you can train it to learn more celebrities. And extract text from images in the video, so you can do optical character recognition. Now, pair that with a service like AWS Step Functions, which lets you put together visual workflows. So Step Functions lets you describe a workflow declaratively as a JSON document, make a graph that looks like one in the middle, and then run these workflows again and again and again. I'll tell you how we apply that with images. So what is a workflow? Do you have problems like this in your life? You want to have a task that failed to get done again, and image processing doesn't work, you want to do it again. Or you want to sequence things. I want to transcribe before I translate, because you can't translate before you've transcribed from the audio. You want try, catch, finally patterns in your code. So try this, try it again. If it doesn't work, now go do something else. You may want to go different directions depending on the outcome of the data. If the file's too big, I want to use a large compute instance. If the file's small enough, maybe I'll do it serverlessly with a Lambda function. And sometimes you want to do things in parallel. They don't have dependencies on each other, so why not take advantage of the cloud and do things concurrently? That's what Step Functions makes easy. Step Functions lets you build visual workflows to coordinate these cloud-based tasks. So what we talk about as an example is on the right, simple image processing workflow. You're uploading files to an S3 bucket on AWS, and you want to make a thumbnail, and you want to use Rekognition to identify what's in that image so that you can build a catalog of these images. And this is a problem that a lot of media companies face. They have thousands and thousands of images, millions of images, and it's too much for any one person or group of people to organize. So on the left, what you have is the image that is uploaded. In parallel, you make a thumbnail, and you extract the images, and you put them in a database. What you see on the right is an actual step functions workflow doing the exact same thing. It's composed of tasks, choices, failure if it's the wrong kind of image, and things being done in parallel. The task state is extracting metadata from that image. The choice state is deciding if it's the right kind of image, and if it is, it goes to the left. If it's the wrong kind of image, it says, can't process this one, and fails. Then it stores that metadata, goes into a parallel process where on the right branch, it makes a thumbnail, does it serverlessly with a Lambda function, and on the left, it goes down and calls recognition and says, what's in here? It comes back and says, I see mountains, I see people, I see snow. You add those tags to a DynamoDB database, and you move on. And you can imagine a single workflow execution for every image you upload. So now you start uploading images a few hundred per second, and this thing is just cranking away, and nobody has to touch anything. So we have a lot of customers on step functions and starting to use the ML services. Customers on step functions do things to automate daily, weekly, monthly tasks. They use it to build distributed applications that scale with their business in the cloud. You can build it to build microservices where you can call something behind an API, run an asynchronous task, and store it when you're done. Some of these names you recognize, some of these names are local. Folks like Thomson Reuters uses it for video transcoding, as does Frame.io. Skycatch is a local company that uses step functions to organize image processing from drones. They take pictures of building sites and assemble those pictures into a 3D map of the building site as the building is constructed. Yelp uses it to process bills for the subscription of all the businesses that they work with. Husei is a social media company that posts celebrity endorsements on social media, and they use step functions to track the impact of those celebrity endorsements as they propagate throughout, say, the Twitter sphere. And Coca-Cola uses this for the My Coke Rewards program that they recently developed, and for syndicating nutrition information to their customers. I'm not going to talk about these in depth today, but all these are available through our website. Now let's talk about that serverless image processing workflow that I showed you. So the same diagram on the left, a state machine that takes an image, makes a thumbnail, extracts from recognition. This is something you can play with today. We have this available with a one-click deployment into your AWS account where you can set up a very simple web front end where you can upload an image, have it transformed, see it come back. And so the image goes up to S3, it triggers a state machine, that state machine extracts the metadata, checks that it's okay, calls recognition, makes a thumbnail in parallel, and then tells Dynamo where everything is so that the front end can retrieve it and show you that thumbnail and the tags that it retrieved. So what that looks like to build is we configure that workflow using JSON. It's a declarative language we call Amazon States Language. What you see on the left is the JSON that defines that graph that's driving this application. It's human readable. You see it's sequential. It says this is a workflow, start at state number 1. In this case, the state is called extract image metadata. That has a Lambda function that extracts the data, and then it says where do I go next? Next, check the image type, and we go on and so forth. And that's how you build up workflows with very, very little bit of coding. That code on the left generates the graph you see on the right automatically in the console. And then from there, you can run individual executions. Everything you see here is also available through the CLI. It's also available through the API. The only exception being the graph is unique to the console, so the visualization is restricted there. So what does it look like when it's actually running? So the left is that state machine again. On the right, this is the front end. It's a very simple front end where back-end developers are not that good at the front end, but it's functional. And what it does is you upload a photo. It processes the image. It gives you back the image as a tag. And what you see here is a photograph of Mount Fuji. It spotted there's mountains, there's nature, there's outdoors. It gives me some of the metadata that it extracted from the file that I uploaded. On the right, I put in a picture of a car. It tells me that it's a car. It tells me it's a coupe. It tells me it's a sedan. And it gives me some confidence on its prediction on each of those elements. And so this is just a simple example of how you can automate tagging images and also with recognition video, tagging videos this way. So build something more complicated with step functions and elemental media services. You can automate a video on demand solution that's completely serverless, so no infrastructure to manage. In this case, you upload videos, the files of your type to S3, and that kicks off a workflow that ingests, processes, and publishes video clips using Elemental Media Convert, which is a fully hosted, fully managed transcoding service on AWS that was launched last year at reInvent. This is also an architecture that's available to deploy now. It's essentially production ready, and again, you can deploy it into your account, modify it, and customize it for your needs. And this is something that's useful, big or small. So whether you're a large production company or a small independent house, you can adapt this to meet your needs. The individual workflows are also driven by step functions, so you have maximum customizability. The whole premise of step functions is it makes your workflows more agile. What you see here are the 3 state machine workflows of step functions. In each case, the source, the media info, communication to Dynamo and to SNS, you can modify these things to change the messages, change how you process events, change what happens in between each step to meet your needs. And again, this is fully documented and available today on AWS Answers. Now, second solution I want to talk about is automating captioning of video. And so this is one that's coming out soon. This is an automated workflow that takes video, extracts the text from the audio, translates that to another language, and then puts it back in the video as subtitles. And it takes advantage of several of the other ML services. In addition to using Transcribe, a newly launched service that can transcribe audio from English and Spanish, it also takes advantage of recognition for scene and object detection to recognize if someone's addressing a group of people or a singular person. So in translations, that can be important for conjugation of verbs. It also uses comprehend to get sentiment analysis, the context of the speech being given, and puts that together to inform the translation, then gets fed back into captioning the video. And you can imagine that as you have hundreds and hundreds of hours of archival footage that you'd like to distribute around the world, this is a way to localize your content by automating the creation of subtitles and captions. So it takes, again advantage of Transcribe, which transcribes audio into speech from Spanish and English. It can handle cell phone audio all the way up to high resolution MP4 files. Handles punctuation formatting, gives you timestamps for each word so you can correlate the transcription back to the video segments you have. Can recognize who's speaking, so if you have multiple speakers, it will tell you which person said what, so you can reassemble scripts this way. And you can add custom vocabulary, so if you have technical terms or you have formal names that it doesn't recognize out of the gate, you can train it to recognize those things for your specific situation. And then Comprehend is another API-driven service that gives you natural language processing. What this means is that you can extract keywords from documents, you can extract sentiment from documents, figure out whether people are happy or sad or frustrated or angry. This is useful, for example, if you have logs from a call center. You can figure out whether customer sentiment is trending the right way or the wrong way. You can look in social media and see what is the general buzz about a product that people are talking about in that environment. This is what Comprehend takes care of for you. The state machine looks a little more complicated than the one that we used for image processing. In this case, this is the one that's being used to drive, depending on whether it's an audio or a video file, transcribing, translating, and building the caption. But you can see with step functions, you can start with very simple concepts and build it up more and more complex as you go and change them as you need. Both these solutions are available on our website called AWS Answers. This is where we put best practices with production-ready architectures that you can deploy in your accounts with full documentation, and they're designed to be easily adaptable to your situation. I know I went fast. I left room for some questions, but everything I talked about today, you can get more in depth on the digital media website for AWS Media and Entertainment. We also have links to Elemental Video Solutions, links to the video on demand workflow I just showed you, and more about step functions and workflows at our website as well. And everything there is available with links to these architectures. Thank you very much. Yes?
Quick question.
Mm-hmm.
So in your current pipeline.
Yes, thank you. In your current pipeline for image processing, you have metadata. You're currently doing face recognition, image recognition. Can you share with us any of the plans to expand the functionality of what you plan, other types of processing AWS plans to offer?
Let me turn the question around. AWS typically is a customer-obsessed organization, and so we tend to respond to what customers need. So I guess the question I'd like to ask is, what would you like to have in these services? And that's how we drive our roadmaps. Well, what kind of functionality you think would be useful for your needs?
Well, for designers, you may want masked images, so you may want to detect the celebrity and then be able to mask that celebrity out,
Mm-hmm.
so that they can then use it, mask that celebrity out, so they can then use it in another celebrity website, for example.
Okay.
More image processing based.
I will feed that back to the team. Recognition team is focused more on the image analysis, but image processing workflows, that would be something that the Elemental team potentially be interested in hearing about. I'll relay that to them. Thank you. Yeah, the question was, Transcribe today supports English and Spanish, and the question was whether we would be transcribing more languages in the future. I can't comment on the roadmap, but I would be surprised if it's not the case.
I was interested to see the visual graph that you're using to capture the state, right?
Yes.
And I'm curious, is that how the user actually programs, or am I using the JSON? I'm curious, is this a visual programming language that you've introduced?
It's a visualization of the JSON. So we introduce a declarative language to describe the workflow, and then we give you a visualization as a sanity check. So that visualization, maybe I'll come back to that really quick and just show you briefly, if I can. I'll just describe it. So yeah, so the visualization comes after you write the declarative JSON, and it gets used in two ways. It's useful as a lingua franca between teams. So when you're working with non-technical stakeholders, it's a good way to have a common bridge. So for example, when Coca-Cola built their nutrition syndication, they were able to work with their nutrition scientists to say, are we transforming the data in the right way? And they'd look at the graph and say, yes, you are, no, you're not. You need to add this step here. It made for a very easy way to converse. When executions are actually running, those states change color on the console. So states that are in progress are blue. When they succeed, they're green. If they fail, they turn red. So when a workflow doesn't work the way you intended, you can look at it and by inspection say, that's where it failed. We keep a complete event log of all the steps in your workflow, so it's very easy to trace back what happened. What's flowing through the state machine is a JSON document that you're transforming as you complete each step, so you have this audit trail that lets you diagnose and debug problems in your workflows much, much faster. So that's what's going on with the visualization.
What I would like to see is actually backwards. I'd love if Amazon offered me the ability to start with the graph, actually, and then produce the JSON.
We will take a look at that.
Hi. Most of the examples I see for recognition are like photographic-based images. Is there something similar for illustration or like 3D rendered objects?
3D rendered objects I can't comment on right now. I don't know what would happen if you gave an illustration to recognition, but I imagine that over time you could train it to recognize illustrations as well. It's trained on photographs, but there's nothing that says it couldn't also be trained on illustrations as well. Okay, one last comment I'll just mention about all these services. They have consoles. It's free to explore. Feel free to go to AWS and just play around with them. You can upload images to Rekognition or try transcriptions on Transcribe, and there's always a free tier where you can explore and just see what happens.
Awesome. Thank you very much, Andy.
Thank you.
Awesome.